Okay, let's look at the second part of 5.1, which is using the method of substitution to solve a system of equations. The method of substitution is going to be exactly what it says. You're going to be doing some substituting. Now look at the way these systems are set up. I don't have everything lined up, my x's lined up with my y's. What I see is one equation solved for, in this case, y. Over here I have one equation that's solved for x. When you have one of your equations solved for one of the variables, it makes it very easy to use the method of substitution. Compare this to the other systems that we had. If you notice, x's and y's were stacked. Over here, x's and y's were stacked. That makes it much easier to use the elimination method. When we've already got it solved for us, one of the equations solved for a variable, it makes it easy to use substitution. So let's work on the substitution method. We're going to target this part that's solved, target that, and do our substitution. So we're going to substitute. We've got to substitute something. Since this says y is equal to 3x, I can substitute a 3x for the variable y in equation 1. So let's do that. Equation 1 looks like x plus y equal 4. But now let me do this substituting. Let me take the 3x and put it in place for y. So I'll have x plus 3x equal 4. Notice how nice that turns out. I only have one variable left to solve for, so one of the variables not cancels out, but gets replaced with a like variable, in this case x and 3x. Simply add them up. 4x is equal to 4, so we get the first part of our solution, the first coordinate, x equal 1. So real simple method, but you got to recognize when to use it and then what you're substituting for. Now I only have half of my answer, so I've got to come and find the second part. So I've got to find y. Well, that's going to be simple enough. It's just another plug in or substitute a 1 for x. So we'll plug in 1 for x. Now you can plug it into either one of the equations, either the first or the second one. To me, looking at this, it would be much easier to plug it into the second one because the value of y is just going to drop right out. So for y equal 3x, if I plug in a 1, I get y equal 3 times 1. Very simple, I get y equal 3. So the solution is the ordered pair 1, 3. So let's use the substitution method for the next one. I see that I have one of my equations, in this case solved for x, as I mentioned earlier. So let's do some substituting. So we're going to substitute. What for what? Since this says x equal 9 minus 2y, that means everywhere I have an x, I can replace it with 9 minus 2y. So we'll substitute 9 minus 2y for x in the second equation, equation 2. So equation 2 looks like this. X plus 2y equal 13. Well, let's now do the substituting. Let's take 9 minus 2y and put it in place for x. So I'll have 9 minus 2y plus the 2y that's already there equal 13. Well, we see something interesting happening here. The 2y's cancel out, which leaves me with the number 9 equal 3. Now remember, in a previous example, we saw this case where all the variables canceled and I had 0 equals 0. That meant they were the same line. When I see an inconsistency like this, 9 is not equal to 3. That inconsistency tells me I have parallel lines. Now that describes the type of lines they are. It doesn't describe what the solution is. So what's the solution if you look back on the previous page? Parallel lines have no solution. And we can either write it out as no solution, or we can use the 0 with the line through. Either way, that represents no solution. Now again, this is getting us ready to understand systems of equations when we get to solve them in the matrix area. So there are some problems in Math Excel I'd like you to look at with this, for this particular section, and so we'll stop it with that.